Hello, welcome back. We are going to be starting with chapter 7. Okay, so hopefully everybody's downloaded or printed a copy of this booklet. This is Exponents. We only have 2 chapters left, 7 and 8. I noticed a lot of people still haven't done the chapter 6 assignment Google form quiz. So I don't know if I'm going too fast or if it's just the weather that's getting so nice. But I'll try to slow down a little bit because we have 2 chapters left, 7 and 8, and a whole month to do it. So let's get started with chapter 7. The first one, which is 7.2, there's no 7.1, it's 7.2. We're reviewing the exponent laws. Okay, so to review the exponent laws, let's say you have x to the power of 2. The x is our base, and the power of 2 is our exponent. Okay, now remember the exponent laws. If we are to multiply with a similar base, what would we do to the exponents? Right? If you're multiplying 2 similar bases, then you're going to add the exponents, 2 plus 3. So we get x to the 5. You can only do this if the bases are the same. If I had, instead of x to the 3, if I had y to the 3, there's nothing I can do there. Right? You can't simplify it any further. It's done. Okay, so this only works for similar bases. It doesn't have to be a variable, though. I can have a number. I can have 5 squared times 5 cubed, and that would equal 5 to the power of 5. Okay. Now, a lot of the times in this package, it says to simplify. This question, if this is not a question, I just made that up now, but this question is simplified. You don't need to plug into a calculator what 5 to the power of 5 is. That would mean you're evaluating. Right? In most of these questions, I don't ask you to evaluate, just to simplify. Okay, as much as you can. All right, let's go over our next exponent law. Let's say I had something like this. Okay, so if we're dividing 2 similar bases, here I didn't write an exponent. If I don't write an exponent, you can assume it to be 1. Right? We usually don't write 1. So here, if you're dividing, what are you going to do to the exponents? You're going to subtract them. So we have 3 minus 1, which is x squared. So there's our second exponent rule. The first one, when you're multiplying similar bases, you add exponents. The second one, when you divide similar bases, you subtract exponents. The last one, which you probably remember, is if you take a power to a power, something like that. Now in this case, you're going to multiply, right? 2 times 3. Why does that actually work? Well, you can think of taking what's in the bracket and multiplying it by itself 3 times. So that's just x squared times x squared times x squared. And now you're just multiplying similar bases. And when you do that, what do you do to the exponents? Well, you add them. 2 plus 2 plus 2. Or you're adding 2 3 times, right? Which would be x power of 6. Okay, so that's our last one. Hopefully you do remember those. There's nothing really new in this lesson. But let's go over a couple examples on the back, and I'll post these as well on the classroom, maybe a little later to let you have a chance to try it yourself first. But there's a couple key ones I want to go over. So example 1, this one actually does say evaluate, so that's important. So the first one is 9 squared, and part B is negative 9 squared, and the last one is negative 9 squared. All right, so 9 squared is 9 times 9, that's 81. Okay, now in this one we have a bracket, and this one we don't. If you have a bracket, that exponent is going to be applied to everything in the bracket, both the 9 and the negative. Since it's squared, we have a negative times a negative, which is a positive. And then you have 9 squared, which is, well, 81. Now, in this case, there's no bracket. So the exponent is only applying to the 9, not the negative. Right? You can think of this as negative 1 times 9 squared. Okay, whereas this one here, right, you would have negative 1 times negative 9 all squared. So this one applies to both the negative 1 and the 9. This one only applies to the 9. So this is going to be positive 81. This one, that negative is still there. You have negative 81. It's a common mistake I see happen a lot. Okay, so just try to be observant of that. Let's try one from example 2, and one from example 3, and one from example 4. And then I'll let you try the rest. All right, so example 2. Usually I say, which one you want to try? Okay, let's try the most difficult one. We'll do D. Okay. So 5 to the power of 15 times 5 to the power of 5 divided by 5 to the power of 18. All right, let's look at this first. If you're multiplying similar bases, what do you do to the exponents? Okay, you're going to add them. So on the numerator, we're going to have 5 to the power of 15 plus 5, which is 20, divided by the denominator 5 to 18. Now when you're dividing common bases, you subtract the exponents. So 20 minus 18 is 2, 5 squared. Now 5 squared is 25, but the question just says simplify, not evaluate, so I can stop there. Okay, let's try one from example 3. Okay, do the first one, we'll do A. So here we have x cubed all to the power of 4 times x squared. So let's deal with the power of a power first. In this case, you're going to multiply them. So 4 times 3 is 12. So you get x to the 12, and then we still have multiplied by x squared. And you're just applying your rules over again. So now you're multiplying similar bases, you're going to add your exponent. 12 plus 2, 14. Okay. Now the next one might be a little tricky. Let's look at one from example 4. This says rewrite each with a common base or the base indicated. Okay, so A says rewrite 64 cubed as a power with a base of 4. And that part B says rewrite with a common base, then simplify. Let's go over part A. So we have 64 cubed. Now how are we going to do this? We need to write it as a base of 4. Okay, well, let me put brackets here. Just throw in some brackets. Okay, and now let's just focus on what's inside the brackets. We'll deal with that cube later. Now, inside the bracket we have 64. Can I write 64 as 4 to the power of something? If so, what? 4 to the power of 2? What's 4 to the power of 2? It's 4 times 4. Right? It's 16. Okay, what if I take 16 and multiply that by 4 again? And I have 64. So this is actually 4 to the power of 3. Okay, you don't need that circle around it though. So 4 to the power of 3. That's the same as 64. All right, so now we can simplify. Here we have a power of a power. So what's 3 times 3? It's 9. So this is 4 to the power of 9. Now look at part B and think, well, how would you do that? What's an easy base to choose? One of them's 3, one of them's 9. But can you write 9 in a base 3? Does 3 to the power of something equal 9? And if so, change it and work with it. Okay, if you have any questions, remember to post it to the Google Sheet. I haven't been getting many questions lately, but post it to the Google Sheet, and I will also post answers maybe later in the day after posting this video. Okay, so good luck. Hope everyone's well.